Students, Business 3502, Investments. We're looking at Chapter 6, which is calculating, let's see our title for Chapter 6. Calculating optimal risky portfolios. And starting then with question 4. Let's make our screen full size and explain what we're given and what the questions are. Okay, we're first of all given in question number 4, T-bills yield 8%, 0.08, and you're an investment manager, you're speaking to your client, and you were asked to calculate optimal risky portfolios. We have, let's say it's an ETF, exchange traded fund, for the stock market, or an ETF that tracks the bond market, or mutual fund. Stock fund, symbol S, the expected return will be 20% in the next year, with standard deviation of 0.3 or 30%. The bond fund, expected return of 12% and standard deviation of 15%. So again, note from our coursework, we would expect the stock fund to be riskier and we would hope that it pays a higher return. Okay. The question also gives us correlation of 0.1, and we should remember correlation can be between -1, 0, or +1. A 0.1 correlation is fairly close to 0, so it says they're not that highly correlated. There's some positive correlation, but it's not that strong. Okay, so first part of the question asks, number 4, calculate the minimum variance portfolio of the risky funds, then go on and explain the expected return and standard deviation of this expected return. So our first step for this, we need to calculate, pardon, I've got wires mixed up. We need to calculate the covariance of each of our portfolio pieces. So remember our formula for covariance, let's say S and B, is rho times the standard deviation of one times the standard deviation of the other. We're given correlation is rho in this formula, so our covariance is going to be between S and B equals 0.1 times standard deviation for stocks, 0.3 times standard deviation for bonds, 0.15. And that will pardon, short pause, I'll get out the calculator. Pardon me, it seems I've left our little calculator back in a classroom from investments. So we'll have to do this just with off the Excel calculations. So this 0.3 times 0.10, this is rho, times standard deviation of stocks times standard deviation of bonds computes to 0.00450. For interest, we can calculate the correlation of bonds with themselves and stocks with themselves. Taking a look at that, pardon. So the covariance of stocks and stocks is 0.10 times 0.30 times 0.30. And that works through to 0.009. Then again, covariance of bonds with themselves, 0.10 times 0.15 times 0.15. And that works through to 0.0025. Oh, missed. 0.00225. Okay. Next then, we can build up a matrix of our variances. A covariance, more correctly. Bonds and bonds, stocks, and stocks. So from this, our matrix calculation for bonds 00225, for stocks, bonds with stocks is 0.0045, and this is going to be the same, 0.0045, and stocks with stocks, stocks themselves, 0.009. All right, then next, calculate minimum variance portfolios, or the least risky combinations. So for minimum variance portfolio on stocks, our formula is the variance of bonds squared minus covariance of stocks and bonds, or bonds and stocks. Remember, this is the same, and divided by the variance on stocks plus variance on bonds minus two times the covariance of our bonds and stocks. All right, so substituting here, our standard deviation on bonds is, back to our first table, standard deviation on bonds 0.15, and we're going to square that to bring it back to the variance, minus the covariance of bonds and stocks, and our covariance of bonds and stocks is 0.0045, divided by variance on stocks. Recalling variance on stocks is 0.30, or that was incorrect, not fully correct. Standard deviation on stocks is 0.3, so standard deviation squared, plus variance on bonds, which is again standard deviation on bonds squared, brings us back to variance, and then minus 2 times our covariance, and covariance between stocks and bonds, again 0.0045. I don't have my calculator to work through that. Let's suffice it to say the variance on bonds is 0.025, so this is variance on bonds, 0.0 just confirming this. Pardon, so 0.0225 I don't have enough zeros. A bit perplexing here. So 0.0225 minus 0.0045. That's my numerator. The denominator, zero point zero zero nine, and plus variance for bonds, 0.0225, then minus 2 times the covariance on stocks and bonds, so 2 times 0.0045. So continuing with this, the numerator simplifies to 0.018, the denominator simplifies to 0.1035, and then the division of that 0.018 divided by 0.0135 is 0.17391. So our minimum variance portfolio for stocks will be 0.17391. Okay. Continuing. Well, first of all, for simplicity, we could know then the minimum variation on bonds is going to be 1 minus minimum variation on stocks, because we only have the two investments to work through. So you can't see this, but on the computer, that comes to 0.82609. So we have one solution, which is to say, if we calculate through to find the weight of the stock portfolio, it's 17.4% of the total portfolio, and 1 minus that should be the remainder, which goes into the bond fund. Okay, but we can prove this by calculating then the minimum variance portfolio for a bond fund. So minimum variation for bonds is, again, the variance, careful with my details here. Oops. The variance for bond funds, minimum investment in the bond fund starts with the variance on the stock portfolio minus covariance of bonds and stocks divided by the variance again on stocks plus the variance on bonds minus 2 times our covariance. So in this, back to my spreadsheet. So changing then, this is going to be 0.30 squared. Standard deviation of bonds, and standard deviation of bonds squared brings us back to variance, minus the covariance on stocks and bonds, which is 0.0045, divided by, this just comes down, 0.30 squared plus 0.15 squared, standard deviation on bonds, minus 2 times our covariance of 0.0045. So extending this, just as we did in our matrix table, stocks times stocks gives us a variance of 0.009, bonds times bonds, a variance of 0.0225. So 0.3 squared, 0.09 divided by, again, 0.09 minus 0.0045, and here plus 0.0225 minus 2 times the covariance 0.0045. So calculating that across, we get further, our numerator changes to 0.0855. The denominator simplifies to 0.1035, and that, if we could show you on a calculator calculating it out, so for you to prove, is 0.82609. Okay, we also, back to our proof, we calculated the weight of the stock fund is going to be 17.4%. So 1 minus the stock fund, the weight of the bond fund should be 0.82609. And our mathematical proof, the weight of the bond fund indeed is 0.6209. So both methods, long form, short form, confirmed that. Now, next, expected returns. Very simple. So expected return on the portfolio is weight of bonds times expected return on bonds plus weight on stocks times expected return on stocks. So now we can use our weights. Expected return for the portfolio is weight of bonds, 0.82609 times, back to our information given, expected return on bonds is 0.12 plus weight on the stock fund, 0.17391 times expected return on stocks, and expected return on stocks is 0.20. And I'll quickly confirm this with a spreadsheet. Uh, 0.1739 times 0.2 plus 0.82609 times 12 is 13. Expected return on the portfolio is 0.1339 or 13.39%. So we've seen now our expected return for the portfolio. Last, calculate the standard deviation for our portfolio, and standard deviation minimum for the portfolio is going to be quite a long formula. The weight times the variance on 1, so that's the weight of stocks squared times the variance on stocks, which is the standard deviation squared, plus weight on bonds squared times standard deviation on bonds squared, plus 2 times the weight of stocks times the weight of bonds times covariance of stocks with bonds. And all of this is, close that off, to the power of 1/2. So the square root of all of this. So we calculate all of this, take the square root. That's like bringing us back from variance to standard deviation, which is what we're trying to calculate. So our standard deviation on the portfolio, now we plug in our respective values. Pardon, get the right page here. So the weight of our portfolio for stocks is 0.1739 squared. The standard deviation on stocks is 0.3, again squared, plus weight on bonds, 1 minus 0.1739, 0.8260 squared, times the standard deviation of bonds, and our standard deviation on bonds, again, pardon, I gotta go back to our given information. The standard deviation on bonds is 0.15 squared, plus covariance, 2 times weight. Let's bring that down. 2 times the weight of stocks, 0.1739, times weight on bonds, 8260, times our covariance on stocks and bonds, and that's 0.0045. So fairly long. Oh, close that off, and remember it's the square root. Oof. So going a little further. This simplifies, I can't show you with the calculator so easily. Or possibly I can. Our standard deviation minimum then is going to be 0.1739 squared, which is 0.0302 if we want, times standard deviation of bonds squared. Back to my table, 0.3 squared is 0.09 times squared zero, 0.081, our first piece, plus 0.8260 squared, (0.6828) times 0.0225, second piece, and then plus 2 times, and we can work all of that out. So 0.1739 times 0.8261 times 0.245 is 0.0006 or 646 if you wish. Close that, and remember we're looking for the square root. And all of this, well, if we wish to do it, (0.000245) plus 0.01535 and 0.00129. And again, that's going to be to that 1/2. I certainly hope this works. So this should then calculate to standard deviation minimum, and let me confirm some of my calculations. So our standard deviation for the minimum portfolio should then simplify to 0.13917 or 13.91%. Conclusion? First step was calculating covariance, and we computed the covariance for the stocks and bonds at 0.0045. Remembering that's rho times standard deviation times standard deviation. Covariance on stocks against stocks, 0.009. Covariance on bonds times bonds. Okay, then step 1. Step 2 is calculate the recommended portfolio weights. This was variance on stocks minus covariance of bonds and stocks divided by the variance on stocks plus variance on bonds minus 2 times the covariance. That's supposed to look like covariance B, comma S. Simplifying that, 0.09 minus 0.0045 divided by 0.09 plus 0.0225 gives us the weight on bonds is 82.609% or 82.61%. We know then, in this case, the weight on stocks is 1 minus 0.8269 or 0.17391. Part 3 to the question, expected returns on the portfolio are our respective weights times return plus weights times return. And that gives us 13.39% as the expected return on the portfolio. So part 4 is calculating the standard deviation of the portfolio. Our formula for this is weight of stocks squared times variance of stocks plus weight of bonds squared times variance on bonds plus 2 times weight of stocks times weight of bonds times the covariance between stocks and bonds. So weight on stocks, 0.1739 squared, variance on bonds, the standard deviation, 0.3 squared, weight on bonds, 0.8260 or 8261, rounding, and again squared, times standard deviation on bonds, 0.15 squared, plus 2 times weight of stocks times weight of bonds times covariance on stocks and bonds. Then putting numbers to this, our weight on bonds squared plus, that seems to be where I've gone a little off. Bear with me a small second. This is 0.0081 or 0.9. That's a problem. That's a problem. This is not 0.0081, it's 0.009. Sorry for that, but continuing on. So our weight of stocks squared, standard deviation on stocks squared, weight of bonds squared, and standard deviation on bonds squared, plus 2 times our entire formula, the weight of stocks times weight of bonds times the covariance. So 2 times 0.0065. And that becomes, this part has a small error to it, 0.002721 if we wish, plus 0.01535 plus 0.00192, all square root. And this gives us finally the calculation, the minimum variance on the portfolio, sorry, that's not correct, standard deviation on the portfolio, the least risky portfolio, or minimum variance portfolio. Our standard deviation is 13.91. So the expected return on the portfolio is $13.39, and the 0.3 standard deviation on the minimum risk portfolio will calculate through to 13.51%. Roughly the same. Note that with this, back to our original, if we can see them together, let me move that up. Our expected return of 13.39% is less than the expected return on stocks, but better than the return on bonds. And the minimum risk, or standard deviation on our minimum risk portfolio, is actually less than both standard deviations. So we've improved the return on bonds, we've lowered the riskiness of the entire portfolio compared to 100% allocation on each side. So definitely recommendable, and if you were the investment analyst or fund manager, that would be easy to explain to your client. With this combination of portfolio, you get some better return and less risk than either one separately. Super interesting. That should give us question 4.